Hi, it's Keith, Sunsynk. I've been talking about inverters, and I realised that not everybody actually understands the different types of inverters. What is it, what actually is an inverter? What is it all about? So let's go back in time, many years ago, when I was, a long time ago. An inverter, used to be a box like this, and it would have a handle on it, and it maybe have a socket on the side of it, and you would connect it into a car battery, a battery like this, and it would wire into the battery, and you would get 240 volts at the socket. And it was really designed for maybe market stalls, places where you needed 240 volt, maybe some lighting or whatever, maybe some certain types of tools. It wasn't particularly high, and these things had a big transformer in it, and they were very simple circuits. So they used some sort of an oscillator of some sort that would take the DC energy into AC energy, and they used a transformer to push it out. You probably heard an aeroplane flying back. We're actually in our Eindhoven office today, and there's an airport across the road. So that's very simple, and these things were around, well, when I was 15, 16, so it's a long time ago. It's 50 years ago, showing my age. So 50 years ago, these things were very commonplace. So let's clear it. So going a bit forward now, those things were what they call low frequency, because it used a big transformer. Very low frequency, terribly inefficient, but that's what existed. And in fact, when I was an apprentice, I used to build them myself because I was really interested and used to build these little inverters. And I had a big old black and white television set, and I plugged it in and I had it in the back of a van, which I had, a small van. And it was magic. Look at this, I can get the TV to work in the van, big television. Wow, how do you do that? And I plugged it in. And it was a bit of a, people had never seen it before. So fast forward a lot, and there was a lot of these high frequency inverters, same sort of thing, and you've probably seen them. There's sort of a box like that, and they were a heat sink, and my drawing is terrible, and it maybe say they've got maybe 1,000 watts on it, and then one side of it you have big connectors which you connect to your battery, and maybe your battery is 12 or 24 volts, and it would connect to the battery, and the back end of it here we have 240 volts. And these things were used for similar type of things. You may use them in vehicles now, but they're also sometimes used as backup up for houses or for businesses. And what they would do is they would connect these into some sort of a changeover relay. So you have a relay here. One side would be going to 240 volts. The contactor here, and then here is your load. And so basically, if I had a power outage, this relay, this changeover switch would clunk over to the inverter, switch your battery on, and suddenly you've got your 240 volt, pretty limited, but your power would be running through it from the inverter. And these things were around for a long time, and you got 1,000 watts, 2,000 watt, 4,000 watt, 5,000 watt. I've even seen great big things this style, 10,000 watts a long time ago. You need huge batteries to power it, and most of the batteries were 12 or 24 volt. The point of an inverter is it inverts the power. It takes DC, this is DC, and it converts it to AC power. And that's what they do. DC moves it to AC. To actually describe the functionality of the product. So what we've got here, the power comes in through to the solar panels, which are mounted on the roof. We have a circuit breaker, 2 circuit breakers from the solar panel, and these are both fed into 2 charge controllers. So the charge controllers are here, and so you see the power coming into the charge controller. On the output of the charge controller, it's coupled here, which then feed back to the battery. So I can show you the battery back, which is outside. So we've got a 500 ampere hour battery pack at 24 volts. Now things are a little bit different, but that's basically what it was doing, because direct current from a battery can't work your TV, and you can't boost it up. You need your 240 volt or 110 volt or whatever voltage you're looking at, but it needs to be AC, thanks to Mr. Tesla, and everything we use is AC, because all our fans, our TVs, everything runs on AC. So we need AC, and that's the reason, that's what the inverter is for. So let me clear all. So going in time, I remember about 15 years ago, and people were talking, there's a new type of inverter coming on. This is quite amazing. You can get a solar panel. This This is the symbol for a solar panel. You get a solar panel, okay? And you can connect this solar panel to this inverter here. And it will connect into this inverter. And they had a thing called, which I'd only ever heard at the time, is an MPPT, maximum power or peak power tracker. It's a tracker. And the tracker means it's to do with the optimization of the panels. And I can explain a little bit more. But that, I'm not going to go too much about how a tracker works, but it basically optimizes the power from the panels. I'll do a little bit of an explanation in a second to show a bit about that. But then this amazing piece of kit would connect to the AC directly. And if you've got load here, your load might be your refrigerators, your lights, whatever. During the daytime, the sun is shining, this thing would make the DC from here, and it would convert AC here. And if you had any extra power, it would shove it out. And you meter, and you had these meters some people call net metering or export meters, and it would export, and you might put a meter here. You might have a meter, a watt meter, and this would measure your export power, and you were getting paid for it. This amazing piece of kit. And I'll be very honest, I was really interested, and I remember looking at these things and how to make one, because at the time they were really complicated. There was no components, there was no single chip that could make an inverter. Nowadays, we call this a grid-tied inverter. Nowadays, people call them string inverters. It's an Americanism because the panels go in a series, but the Americans call it a string. Say a string or a series, and that's the reason. And nowadays, people call it a string inverter because it takes a series of solar panels will go into this, and this can export the power out. And these were really, really state of the art. But the problem with these things is sun is shining. If you're at home, you use the energy. If you're not, a little bit, it goes on export, and the power's lost. But you may get paid, and generally people did quite well with it, because the tariffs paid them. But for the power company, it's not much use anymore. It's just lost money. But this went well, and there's many of these systems still in existence, because let's face it, the technology is still fairly new. But this type of inverter, and these are still very, very popular, especially with larger installations. And these type of inverters can be banked together. You can put lots and lots of these together. And the same way, what they've also got now, and I'll clear up, you've got your solar panel, and you might have your panel, and you might put a small one of these inside the panel. So the panel connects inside to the inverter, and the inverter will connect directly to the AC. And then you may have another one here, and then it connects into here. The panel connects in, and then this goes to the AC, and you've got a common AC line. So this will connect to the AC line, and so this is very, very popular. And these things still exist, and these are often referred to as microinverters. And microinverters is a tiny inverter. It's still the same thing. It's still like a string inverter or a grid-tied inverter because it's tied to the AC line. And the nice thing about these is you can put lots and lots of them, and there's lots of new features and gadgets and gizmos people put on. And for example, you have to have rapid shutdown because, of course, these things can't shut down easily, so they have some methods of switching them off for safety. And again, like these are very, very popular. So let me clear all this. So we're basically talking about the history of inverters. So I've spoken to you about the very beginning inverter, and then we spoke about the grid-tied or the string inverter, and then just looking at microinverters. But all these things have one thing in common. They can't store energy. When the sun is shining, they can use the energy, but they can't export it, they can't do anything with it. And so therefore, if you've got a meter, some countries have had a meter that turns backwards. So when you export, it goes one way, and that is often referred to as net metering. Most countries now, net metering is becoming less and less viable. And the reason they had it at the time is because solar panels were so expensive. You just sort of, maybe 15, 20 years ago, you're looking at $5 US or $10 US a watt for a solar panel. Now, what's the wholesale price of a solar panel or what? 10 cents? Look at the difference. $10 US, 10 cents. Nowadays, it doesn't make sense because the panels are so cheap and the arrays are becoming bigger and bigger. And the power companies are actually having to put their transformers and all the control gear, it's sending the power back. And they've got to be careful because they can't send too much back because the transformers, the substations can't handle it. because suddenly it's all going one way and the utilities are still going to maintain it. So a new type of inverter appeared now, which is basically a cross between the string inverter and the good old-fashioned simple inverter, which was the battery inverters they had many years ago. And they call these inverters hybrid. It's a common name. In some countries they call it multi-mode inverters. We call lots and lots of things. So we've got this new type of inverter, but a big inverter. It's a great big inverter. And the Sunsynk fall into this category. And so this type of inverter, it has the best of both worlds. It has the ability to connect to a battery. So I put the battery here, and it connects to the battery. And it has the ability to connect to the 240 volt. But it also has other abilities because it has its changeover. You don't need any relay switches, whatever. It all built in. And it has the other thing is it can connect directly to the solar array. So it has its MPPT. MPPT has then built in. There may be several of those. So it has your MPPTs, and the solar panels can connect directly to it. Your 240 volt and your battery. So it is actually a cross between a storage, an old-fashioned simple inverter system that you use maybe for a backup or to power your lights at a market stall, or a string inverter. We've got the best of both worlds. But there is also a slight difference, because you also have to understand within this type of category of inverter you have two types. Now some of them can have the ability to export. They can control, this is on the grid here. So some inverters can export power, some inverters can't. So you have to understand there are differences, there are subtle differences. If the inverter can't export, it can connect to the grid, it can connect to the panel, it can connect to the batteries. But it's basically an off-grid type inverter. It's still an off-grid inverter because you can't get the benefits of a full true hybrid. The thing with a true hybrid is it has other benefits because you can export power, you've got time of use, you've got lots of true benefits. So let's focus a little bit on the clean oil. Let's look a little bit about the inverter. So we talk about inverter, that's my big inverter there. Well, Sunsynk. Best one in the world. I'm not biased, honest, but we've got a Sunsynk inverter. We connect to a battery. Now, understand one thing about the batteries. Most common battery voltage is around 50 volts. Why 50 volts is because it is a safety. 50 volts falls into a different directive. Below 50 volt has a safety because you can touch your 50 volt and you're not going to feel it. If you go much above it, if there was a 100 volt battery and I touch across the terminals, I'm going to get a belt and it will hurt me. At 50 volt, I'm not going to, maybe if I'm super sensitive, I might get a tingle, but very little. It's not going to do me any harm. It's not going to hurt me. Once you start moving upwards on the voltage, it becomes dangerous. But 50 volt has a big problem. So if we're looking, this type of inverter is connected to a 50 volt is called a low voltage, I put LV inverter. It's a low voltage inverter. Low voltage referring to the 50 volt. In the world of AC, low voltage is below 600 volts. Is the low voltage directive is below 600 volts. And medium voltage is up to, I think, and you're probably going to correct me if I'm wrong, is around 33,000 volts. And then high voltage is above 33,000 volts. Huge high. But we often refer to inverters as low voltage or high voltage. And the high voltage relates to the battery. So why would you actually ever use a low voltage or a high voltage inverter? So supposingly I've got a 5,000 watt inverter, 5,000 watt or 5 kilowatt inverter, and I've got a 50 volt battery. So what's the current it can draw? You look at the current, 5 kilowatt, 50 volt battery. What was the current from the battery? Well, simple as 100 amp. That means my battery connection is going to be 100 amp. Internally of the inverter has to carry 100 amps. It's got to be more than that, but the general running power is 100 amps. So everything's got to be running 100 amps. The cable, everything's got to be protected to that. But suppose if I made that a 500 volt battery, and the current here, I'll use my eraser. That doesn't work. Sorry. The current here would become 10 amps. Pen. 10. So 5,500 is 10 amp. It's 1/10 of the current. So what you're transferring some of the technology from the inverter into the battery, but your current is a lot less. So you say, well, why doesn't everybody do that? It's a good idea for certain things, but it also has certain safety. And you've got to consider the installation, because when you're installing 500 volt battery array, if you touch across a 500 watt battery array, the very, very best that could happen to you is you're going to A&E. The worst that can happen to you, you'll be dead. Within seconds, it's dangerous. So the installer has to carry a lot of protection, but protection equipment. The installation standard has to be of a certain standard. It's not a DIY. It's dangerous. And the DC, 500 volt DC is really, really dangerous. And I talk about it using protection gloves, using masks, using everything. You must be careful. At 50 volt, of course, the high current is dangerous, but you're not going to get electrocuted. But the high current is dangerous. But at 50 volt inverter, which we call a low voltage inverter, is much, much more expensive than a high voltage inverter. And so the Sunsynk, we actually do both. If we're having to use the big systems and we're going to the 50 kilowatt, 100 kilowatt, of course it has to be high voltage, and that's what we're using on in the gate and the containerization. So we have to use that because the currents are so high, you can't justify it. And you have other problems to do with imbalancing of batteries. We're not going to talk about. So what I've been talking about is the types of the inverters. And rather than go through everything, we talk about one, which is string. So string inverter, which is a grid-tied inverter, string being the solar panels go in series. Two, okay, we spoke about the battery inverter. In fact, I actually spoke about it the other way around, it doesn't matter, battery inverter. And this is what you'd use in your caravan or whatever. And the battery inverter could have mains coupled or not mains. Many of them have mains on it, but it's not a hybrid. And three, we talk about hybrid. So within those categories, there are lots of subcategories of inverter. So on a hybrid, you've got low voltage and you've got high voltage category. I call them A and B. On a battery inverter, you've got just battery. So you've got battery only. And you've got battery mains. UPS, maybe a UPS, uninterruptible power supply. So that would come under a battery, but it's battery only, battery mains. And then on a string inverter, which is obviously connecting to a series, a grid tied, then you've got the standalone, and then you've got micro. So you've got subcategories. So string would be standalone, a single unit, and these could go huge. On a standalone, these can go megawatts, and you probably see these massive fields of solar panels. I can guarantee these will be these big string inverters, maybe megawatt, 2 megawatt, 100 megawatt of string inverter. You've got microinverters, which you often see on roofs and used with various reasons. Some companies specialize in selling microinverters, and that's what they focus on. So you'll see microinverters. Battery only systems, you will see this typically in your caravan, maybe certain things. Battery mains, UPS, maybe one of these units you have by your desk. If the mains fails, it will switch your computer over. You might have a portable unit if you've got load shedding, or if you're out in the field, you might have certain things. So this and these often can have inputs for solar panels as well. And then you've got your hybrid, you've got your low voltage and you've got your high voltage. But you've got lots and lots of things going on. But there's a true hybrid. If you talk about mains UPS, and as I said, you can't export. So understanding the differences, I'm showing you three categories: string, battery, hybrid, and subcategories between standalone, micro, battery only UPS, low voltage, high voltage. So of course, Sunsynk, we tend to focus here. We focus on the low voltage and we focus on the high voltage. High voltage is totally professional, absolutely specialist professional. It's not for DIY. None of it really should be DIY. And as an electrician myself, I cringe when I look at some of the DIY things that people do and the certain sites you see on the internet. So quite frankly, none of it should be DIY, because even if we're just looking on a simple hybrid with a 5,000 watt battery, the energy in that 5,000 watt battery, and I saw recently in Germany, I think a 5,000 or 10,000 10 kVA It actually exploded a whole house. One battery brought down a house. I'm not going to say about the quality of the battery and lots of things, but it was a battery bought on a very famous Chinese website. But nevertheless, you've got to be very careful and how it's installed. You often see fires because people don't understand the cable thicknesses, because when you're looking on your low voltage side, your cables are much thicker than on your AC side because of the currents. So I hope this video is useful, just trying to simply explain the differences between inverters and understand the differences. And don't suddenly compare the price of a string inverter that's priced in a low voltage hybrid, or compare a high voltage hybrid with a low voltage hybrid. They're all different. Pricing structure is different because they're very, very different product. But with the Sunsynk, you get much more than this, and you get a unit that can control export, it can earn you money. But I'll explain more about it. But I hope this is useful and just explaining the differences. And you know what? The sun's come out, fantastic. Keep following us. Thanks, bye bye.